isomerism in the constitutional isomerism. So the first one is skeletal or chain isomerism. Now the skeletal or chain isomerism has to do with those isomers that have the same molecular formula but different arrangement of their what? Carbon atoms. Okay? As a result of what? Branching. So the carbon atoms can branch and then form a new compound that is different from the original one. Example, let's talk about butane. Let's use butane as a case study. Butane, okay? Butane is C4H10. If you forget, remember that butane is CN, H2, alkane is CN, H2N plus 2. So when you put butane means 4 carbon, okay? When you put 4 here, you have C4. 2 times 4 is 8 plus 2 is 10. Now, what are the isomers of this butane? Or what isomers can it possibly have? Remember that butane, look at butane, look at how to draw butane. This is butane. Butane has something like this. So, look at this molecule. This butane. Now, you notice that these carbon atoms are all part of the longest chain, part of the parent chain. The moment you branch one of the carbon atoms, you form an isomer of butane, and that isomer is called chain isomer because the isomer is as a result of what? The rearrangement of the what? Of the carbon atoms. Okay? So if I branch this carbon to this side, I will have something like this. Look at this. I'll have this. I'll have this. So now, this molecule you are seeing here is different from this, and it still has the same formula as C4H10. Let's check. Carbon is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is still C4H10. This one also here is still 1, 2, 3, 4, C4. And I have 10 hydrogen around it. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This compound here is different from this compound. This compound here is 2-methyl-propane. Okay? This compound here is 2-methyl-propane. So, and this is also called isobutane. You can also call it what? Isobutane. Isobutane. Now, looking at this molecule and this molecule, this one here, are two different compounds because they have different what? Structural formula, and their properties are not the same. So because the arrangement is as a result of the change in the position of the carbon atom, we say that the isomerism exhibiting here is called chain or skeletal isomerism, and these are called chain or skeletal isomers. So butane only has two isomers, itself and isobutane. There is no other way you can rearrange this to get a different molecule if not any of these two. So the isomers of butane is just itself and this. So this isomerism does not only happen in alkanes. You can also see it in alcohols. You can also see it in haloalkanes. You can also see all this chain isomerism happening there. Okay? It mustn't be just one functional group. So if you go to the app and check more questions, we are going to look at another problem for us to illustrate this much more better. Another example of this skeletal isomer, it can be seen in pentane. Okay? Pentane. Pentane being C5H12. Right? C5H12. How did I get C5H12? Remember, the formula for alkane is CnH2n plus 2. So 5 times 2 is 10 plus 2 is 12. So this have got 12. 5 is already in the Cn. So we have this. So the first isomer is the straight chain isomer, right? 1, 2, 3, 4, 5, which is the normal pentane. Okay? So this, I will not bother putting the hydrogen. This is the normal pentane. Okay? So if I want to get the second isomer or the second chain isomer, I will branch one of the carbon somewhere here. So I'm going to have something like this. Instead of having going further, I'll branch this. So I have this. So this is another isomer. This is another isomer. Okay? So if you take this one to this place, it's still the same thing. So there's no need taking it to this place. So it will still be the same. This compound here is 2. This is 2-methyl. This is 2-methyl butane. otherwise called isopentane 2. Okay, so you can also, this compound is still the same thing. If you take this carbon here, it's still the same compound they are going to generate. Another way we can also get another isomer is to branch 2 carbon. Okay, how do I branch 2 carbon? I have something like this. I'll branch 1 carbon here, branch another carbon here. So this is still 5 carbon. So if you complete the attachment, you will still have the same number of attachments of hydrogen, which is still 12. Okay, so this one has 2 branches, but this one has only 1 branch. So this one can also be called 2,2-dimethyl propane, or otherwise called neopentane. So this has 2 names, either this or this. This also has 2 names, either this or this. So this one is the normal pentane. This is the N-pentane. The first one I've written here is N-pentane. So you notice that pentane has 3 isomers. The first one is itself, normal pentane. The second one is the isopentane or 2-methylbutane, while the other one is neopentane or 2,2-dimethyl propane. So when we learn about this branching, you notice that this branching it has an effect. The more the branching, the lower the boiling point. So as you move from pentane to isobutane to neopentane, the boiling point decreases because branching increases the surface area and lowers the boiling point. So in chain of skeletal isomerism, the isomers, most of them, they appear as a result of the branching of the what? Carbon atoms. Okay? So that is what we mean by what? Skeletal or chain isomers.